Hello, thank you for checking out Mr. Ware's videos, and today we're looking at Unit 2 Assessment Guide. Unit 2 Assessment Guide. And what we want to do for problems 1 through 6, we want to tell whether the relationship represents a linear, exponential, or neither. Okay, so let's look at number 1. In number 1, we have a straight line, not like what I just drawn, but a line going straight right here, and it's not curved. So that's going to be linear. All right, next, exponential. Oh, I'm sorry, next, number 2. Number 2, we've got some numbers here, 2, 4, 8, 16. That's the output. The input here is 1, 2, 3, 4. So what we want to know is, what is this? Is this linear or exponential? One way to find out is if you do 4 minus 2, you get 2. That's this one minus this one. Now if we do this one minus this one, 8 minus 4, is it the same number? It's not. Okay, so since it's not the same, that's make it not linear. Okay, now we'll do the same numbers but divide. 5 divided by 2. I'm sorry, 4 divided by 2 is 2, and 8 divided by 4, that's also 2. So that checks out. So that means you're multiplying by 2 each time. That makes it exponential. All right, let's look at number 3. A heavy punching bag contains 90 kilograms of sand, has a small hole at the bottom. The punching bag loses 1.2 kilograms of sand through the hole every hour. 1.2, so 1 hour, 1.2, another hour, 1.2, another hour, 1.2. So it's minus 1.2 every hour. The same amount is constant, right? So that's going to make it linear. Okay, number 4, unlike the straight line we had earlier, you got this curved line. So that's also going to be, well, that's going to be exponential. All right, let's look at 5 and 6. All right, 5 and 6 are actual equations here. And here we've got this is an explicit equation. We have the first term here. We have the second term. That's the common ratio that you keep multiplying. And you got an exponent. So that's going to be exponential. Okay, the second one here, or number 6, is a recursive. It gives you f of 0 is equal to 7, meaning the first term is 7. You got f of n is equal to f of n minus 1, and then take away 2. So that means the next term, or the now term, is equal to the next term, or the previous term, I should say. The next term is equal to the previous term minus 2. So you take it away 2 each time. That's going to make this linear. All right. So here it says use the table below to write an explicit equation. So we want to write an explicit equation, and this is similar to the lesson we did with the toolbox, trying to figure out what tools go where and how. Here, what do we have? We have the points, okay, and that's all we got. We got each point here. Can we take the points and find out any other information? Well, it'd be very difficult to find the y-intercept, okay? So one explicit equation that we probably can't use is y equals mx plus b, okay, because we don't have the y-intercept, all right? But what we can use is y is equal to x minus x1 plus y, okay? That's the point slope formula, okay? But in order to do that, we'll need the slope. Oop, left out something. Fix that. Y is equal to m times x minus x1 plus y. So in order to make that work, we have to find the slope. So how do we find the slope? Well, we're going to take these 2 points and plug into this formula. This is the slope formula. It is m is equal to y2 minus y1 over x2 minus x1. All right, so I'm going to plug in some points here. So I'm going to let this be my first point, and this will be my second. And I got an x and a y. All right, so I'm going to take that second point, and that's going to be negative 42 minus the y in my first point. I'm going to change this and make this smaller. Negative 42 minus negative 49. And we'll put that over, zoom in a little bit, negative 58 minus 57. Okay, actually this is positive 58. So positive 58 minus 57. Alright, so now I got negative 42, and you got to change these signs here to plus. That's going to mean your m is equal to positive 7 over 1, and that's going to equal to 7. Okay, now we have the slope. We can plug it into the formula. So you got y is equal to, I'm going to go back to black now, 7 times x minus, and you can pick either point you want. I'm going to pick the first one, 57, minus the y, this is y1, I forgot to put that, but minus 49. Let's zoom out here so you can see all of that. Alright, so let's take a look at the next problem. Here we're trying to graph f of x as a continuous function with a domain of all real numbers. Okay, so first let's just graph it. Okay, 0 and 3, 1 and 6, over 2 up 9, and over 3 up 12. Okay, and we're adding 3 each time, so this is going to be linear. But it's a continuous function, so everything in between is connected. Okay, and since it goes on all real numbers, we're going to put arrows on the end here and show that it keeps on going. All right, let's take a look at our last problem. Okay, fill in the table with the output values for g of x equal to 3 times 2 raised to the x. So we got an explicit exponential equation here, and I'm just going to plug in these numbers. I'm going to do 3. I'm actually going to change this. Let's pick blue this time. All right, we got 3 times 2 raised to the 0, 3 times 2 raised to the 1, 3 times 2 raised to the second, 3 times 2 raised to the third. So now we're going to do 2 to the 0. Anything raised to the 0 is 1. So that's going to equal 3 times 1, which is equal to 3. I put 3 over here. All right, now we're going to do 2 to the 1, and that's going to equal 3 times 2 to the 1 power be 2, and then 3 times 2 is 6. put that over here. All right. Next, we're going to do 2 to the second, and 2 to the second power. 2 times 2 is 4, and then 3 times 4 is 12. All right. Next, we're going to do 3 times 2 to the third, and that'll be 3 times 2 times 2 times 2, which is 8, and then 3 times 8 is 24. 12 here and 24. As you can see, we're doubling it each time, so we're multiplying by 2. And that's it. That is the review here for Unit 2. I want to thank you for checking out Mr. Ware's videos. Have a nice day.